Hi, good morning. Today I'd like to explain about the inverse trigonometry functions. The last week we have discussed about these horizontal line test to test whether the trigonometry function is one or not. Here, this is a horizontal line test, and we have understood that all the trigonometry functions are not one. We can convert that function into one by converting that by restricting the domain into like this. These are the restricted in the restricted domain. The trigonometry functions are these: sine, cos, tan, cosec, sec, and cot. Okay, these are the figures corresponding to that, and look at this range also. We have to remember the domain and range correctly. Minus pi by 2 to pi by 2. Then this is 1 range minus 1 to 1. This is then this type of this is 1. Here domain 0 to pi, range minus 1 to 1. This is 1. Inverse trigonometry functions. Here y equal to sine inverse x. These are the definition of the inverse function. Sine inverse x if and only if x equal to sine y. The domain is minus 1 to 1. The domain means the domain of x. Y equal to cos domain of x means that is a codomain of sine x in the restricted domain. Y equal to cos inverse x. These are we have looked in the last class. These are the graph of this function. Can you memorize this? Yes, okay. So move on to the example. This is very simple. That's why I'm dealing with through this. Evaluate sine inverse of 1 by 2, cos inverse of minus root 3 by 2, tan inverse of root 3, cos inverse of 0.6. Look the first question, sine inverse 1 by 2. For that, let y equal to sine inverse 1 by 2. And we know from the formula means this is the formula, y equal to sine inverse x if and only if x equal to sine y. So here sin y equal to 1 by 2 by the formula sin y equal to 1 by 2, since y must lie in the interval minus pi by 2 to pi by 2, we see that y equal to pi by 6. Therefore, sin inverse 1 by 2 equal to pi by 6. Let y equal to cos inverse minus root 3 by 2, so that by the formula cos y equal to minus root 3 by 2. First question is clear. In the second, this is cos y equal to minus root 3 by 2. Minus root 3 by 2 lies in the interval. Then y lies in between. Which interval? The domain of cos. Domain of cos is 0 to pi. In the 0 to pi, minus root 3 by 2 value comes from 5 pi by 6. So cos inverse minus root 3 by 2 equal to 5 pi by 6. If any doubt, please ask me. Let y equal to tan inverse root 3. So that y equal to root 3. Since y must lie in the interval minus pi by 2 to pi by 2, we see that y equal to pi by 3. Therefore, tan inverse root 3 equal to pi by 3. Therefore, we use the calculator to find cos inverse 0 to. Here, we use the calculator. There is no need. Y equal to tan inverse root 3. It is very easy actually. Next question we have to discuss once more. Evaluate cot of sine inverse 1 by 3. For that, substitute theta equal to sine inverse 1 by 3. Here theta is the angle in the right angle with opposite sides of length 1 and sine theta equal to 1 by 3 means 1 is the opposite sides and 3 is in the hypotenuse. So we can find out very easily the other side. That will be 2 root 2 by the Pythagoras theorem. So cot of sine inverse 1 by 3 equal to, that is a cot theta. This cot theta. Cot theta, what will be the cot theta? Cot theta is adjacent side by opposite side, 2 root 2 divided by 1. So this is 2 root 2. Right. So listen very carefully. F of f inverse x is equal to x and f inverse of x is equal to x only in this interval of x. In the restricted interval, this is happening. There is sine of sine inverse x equal to x in the interval of domain of x. What was the domain of x? The domain is -1 to 1. Suppose x is equal to 2. At these x is equal to 2, this result is not satisfied. Sine inverse of sine x, the domain of x, sine x, that is minus pi by 2 to pi by 2. Cos of cos inverse x equal to x, or -1 to 1. Cos inverse of cos x equal to x, that is the domain of cos x, that is 0 to pi. Tan of tan inverse x equal to x, for the domain of x is, domain of tan inverse x means -infinity to infinity, and tan inverse of tan x, that's equal to the domain of, this is happening in the interval minus pi by 2 to pi by 2. And also we have to remember that the sine inverse of sine pi is not equal to pi, because sine inverse of sine x equal to x only in the interval minus pi by 2 to pi by 2. So in the case of pi, this is outside this interval, so that at that point this result is not satisfied. So listen, this result is satisfied only in this interval. Look this example. Evaluate a sine of sine inverse is 0.7. 0.7 lies in the interval -1 to 1. So what was the domain of sine inverse? That is the sine inverse x domain. Sine inverse x domain is -1 to 1. So 0.7 lies in the interval -1 to 1. So sine of sine inverse 0.7 is equal to 0.7. Cos inverse of cos 3 pi by 2. Notice that 3 pi by 2 does not lie in the interval 0 to pi. 3 pi by 2. Here the interval is, the domain is the domain of cosine. Cosine is 0 to pi. 3 pi by 2 is not lies in the interval 0 to pi. So we have to use another formula. Cos 3 pi by 2 is equal to 0. So 0 lies in the interval -1 to 1. So we have cos inverse of 0, which is equal to pi by 2. Okay. I think you can understand this very easily. So can I move on to the next topic? Yes. So the next is the derivatives of inverse trigonometric functions. Derivatives of inverse trigonometric functions. The rules for differentiating the inverse trigonometric functions. Derivative of sine inverse u 1 by root 1 minus u square into du by dx. What was the derivative of sine inverse x? What was the derivative of sine inverse x? Sine inverse x derivative is 1 by root 1 minus y square. Use the chain rule. If you use a function of x, then again d into du by dx. Cosec inverse x is minus 1 by mod u into root u square minus 1 into du by dx. Cos inverse x is minus 1 by root 1 minus u square. Tan inverse x is 1 by 1 plus u square. Cosec inverse x is minus 1 by mod u into 1 by root u square minus 1 into du by dx. Sec inverse x is the positive of this one. Cot inverse x is the negative of this one. Okay. Please see the similarity between this sine inverse, derivative of sine inverse and derivative of cos inverse. Only negative sign is different. Look this tan inverse and cot inverse. Only negative sign is different. Cosec and sec inverse. Negative sign is different. Okay. How will you prove this? The first way, look the first one, y equal to sine inverse x. So that sine y equal to x for the interval, this one. Differentiating with respect to x and cos y divided by dx equal to 1. So divided by dx equal to 1 by cos y. 1 by cos y is root 1 minus sine inverse sine square 1 minus sine square y. So this is root 1 minus x square. So divided by dx equal to 1 by root 1 minus x square. So this is result. Okay. So next example we can move to the next example. Example 4. Find the derivative of f of x equal to cos inverse 3x, g of x equal to tan inverse root 2x plus 3, y equal to sec inverse e raised to minus 2x. Can you understand this? Derivative f dash x is equal to, here the derivative of cos inverse 3x, here u equal to 3x. So minus 1 by square root of 1 minus, in the place of here u, here 3x into derivative of u. That is minus 3 by root 1 minus 9x square. Next is the derivative of the question. Tan inverse of root 2x plus 3. Please look these examples also. Okay. Example 5 also you have to read. Next class we will discuss about the integration involving inverse trigonometric functions. Okay, thank you.